Yo, good afternoon, viewers of YouTube. My name is Tyler of Chico Crypto, and welcome to another informative episode of Breaking Down the Blockchain. Today, we're going to pick up where we left off with Elastos. I've spoken about a general overview of what Elastos is, the dual blockchain structure of the Bitcoin blockchain and the ELA main chain, as well as broke down the side chain structure. So, Elastos is the holy grail for decentralized systems. The blockchain is used for ownership of data, while the P2P network is used for data transfer. And the SDK, runtime, and virtual machine essentially replaces the need for a cloud or server to store information and files. So, today we will be diving into the P2P carrier network that allows data transfer from person to person. Next week's video will dive into the SDK, runtime, and the virtual machines. So, to begin, think of Elastos in levels. Bottom level is the Bitcoin blockchain. Above that is the Elastos main chain. Sitting on top of the Elastos main chain is the sidechain blockchains, APIs, and light nodes, as well as ID services and the smart contracts. Connecting your phone and devices to the blockchain structure and allowing the free, secure flow of information is the Elastos P2P carrier network. This carrier network surrounds the blockchain structure and connects to each sidechain. The P2P carrier is for the file transfers and allows end-to-end transfer of data from one person to another. And it has little to do with the below blockchain. Some, but not much. Now, some people say, why don't we just use the blockchain for the file transfers and ownership of data? In theory, yes, this is amazing, and it does create security and clear ownership. Now, Rong Chen has explained this many times. If you want to put an entire game or complex digital asset on the blockchain, achieving consensus on it would eventually take forever. The ledger would be so big that every additional transaction would make it even slower. The only thing that would process the ledger would be a high-powered computer, leading to centralization of these nodes. People then argue, what about the off-chain scaling solutions such as sharding, Plasma, Raiden, and Trinity? Well, this may fix for non-fungible data such as payments, but it would not be a solution for the complex data with many different attributes like games and content. The carrier takes over all of the network traffic between the virtual machines and conveys the information on the application's behalf inside your phone or device. When using an application with Elastos, all of your data stays on your device. If you want to share that data with someone else, it isn't routed through the internet and then through a centralized server. Instead, you run the Elastos runtime on your device, transforming your device into its own virtual machine and node on the P2P carrier network. Each node or device provides its own processing capacities and capabilities, and the file transfers happen through the carrier. Let's now look into the main features of the Elastos carrier. The Elastos carrier is decentralized and end-to-end encrypted. What does this mean? Well, an ID authentication step is required before any information is transferred through the carrier. As we know from my previous videos, this ID authentication is performed by the Elastos main chain or one of the ID services side chains. This feature of identity creates trust in information exchange and prevents DDoS attacks from happening. With the current form of the internet, computers can spam servers with multiple requests for information through spoofed or zombie computers. This is all allowed because there is no identification step when transferring data or requesting data. Elastos is a peer-to-peer communication network, which means all the network traffic is exchanged from person to person and never goes through one of those centralized servers. This is opposite from the traditional client-to-server network, where traffic is routed through a central server before going to people's devices. With the current form of the internet, the information put through it is routed through these centralized servers and can be intercepted by sneaky black hat hackers. There is no such thing as a man-in-the-middle attack with the Elastos carrier. When you run the Elastos runtime on your device, this turns your device into a network connection node for P2P communication. The nodes are able to efficiently transfer data because they are UDP based and use NAT traversal techniques. Any type of data, 4K video, audio streaming, or text messages can be sent effectively from node to node. So let's now break down the advantages of the Elastos carrier compared with the internet's form of communication based on TCP/IP. With Elastos, you need authentication before connecting, and this allows known bad actors' IDs to be blocked or blacklisted. With TCP/IP, data packets can and will be intercepted as long as the attacker knows the target's IP address. Data with Elastos carrier is encrypted, immutable, and cannot be imitated. Data with TCP/IP is plain text headers, which enables it to be transformed and imitated. With the carrier, there is a decentralized relay, which is person-to-person, making data routing unpredictable. With TCP/IP, web data storage is unsafe in centralized servers, and packet filtering can steal sensitive data. With the Elastos carrier, there is no spam attacks or DDoS attacks, and there is no cost for storage since the data never leaves your device. With TCP/IP, you need to have frequent changes of your IP address or domain name to prevent those spam attacks and DDoS attacks. And what that equals is extremely high costs. A simple explanation of all this is the Elastos carrier is a P2P network combined with decentralized ID. The carrier leverages the blockchain and trusted ID services, making communication reliable, trustworthy, and secure. Decentralized applications are able to utilize this, and information is able to flow how it was supposed to, freely and securely. Now everyone knows I love working products, and Elastos is the team with a working product that is light years ahead of other blockchain projects. One of the first decentralized applications utilizing the P2P carrier is a messaging app, similar to Telegram. I will officially name it right now, Elastogram. So here's a video from KP Woods, another Elastos evangelist like myself, showing off the decentralized messaging app in action. Check it out now.
Alright, on the left I got a chat app window open, and the same thing on the right. Let me log in on the left as, actually not, I will do left chat screen, whatever, app password really. This is a demo app, so it doesn't really matter. I'll do right chat screen, whatever. Now, you see that this ID, this is a unique ID that's assigned to this particular app that's running on this VM, and this is another ID that's assigned to this particular app running on another VM. So, the first thing we can do is I'll just copy that, and then, I don't know, I'll try to send a request here. Hello, left chat screen. Actually, I'll just do left screen. Let's see how long that takes. Oh. Oh, there it is. On the left, I got a message. Hello, left screen. Alright, I'll send it back. Oh, hello, right screen. And look at that. That was pretty quick. Are you using carrier SDK for Node.js? That is pretty quick after you install, after you add each other. And all this communication is happening, you know, peer-to-peer.
Well, viewers, I hope this episode broke down the carrier into easy to understand terms, as well as highlighted its advantages. Elastos is a beast of a platform with many, many parts, and it's not easy building a new type of internet. Next week, we will dive into the Elastos virtual machine, runtime, and the software development kit, bringing us one step closer to understanding the entire Elastos ecosystem. Well, cheers, viewers, and as always, I will see you tomorrow.